Okay, so what I want to look at is solving simultaneous equations. So the first thing I want to do is talk about what I mean by simultaneous equations, and then we'll look at how we solve them. Probably the most difficult thing about this sort of thing is not actually solving it. Initially it is. How do you find out what these values are? And there's three ways that we're going to look at to do it. But once you've practiced and you've got the idea of these things, that's not the difficult bit. The difficult bit is setting up the equations in the first place from a problem. And that's what you've got here. You've got a series of problems, hopefully most of them sort of engineeringly biased. But what we can do to solve these things is to set up an equation. And then once we've set up the equations, we can use these ideas of solving simultaneous equations to find out what the missing values are. Let's have a look at the first one. This is B. She invests £30,000, part at 5% and part at 8%. The total interest on the investment is £2,100. So she's invested it, and after a year she gets this. The question is, how much did she invest at each rate? So she invested part at 5% and part at 8%. What fraction did she invest at each rate? Well, we can work that out. What we have is a couple of unknowns. We don't know what she invested at 5%. So let's call that X. That's her 5% investment. And we don't know what she invested at 8%, so let's call that Y. I have two unknowns. And if I have a situation where I've got two unknowns, that immediately brings problems in my mind. If we think back to the drill question that we've just been looking at, say this one up here, there's only one unknown in that equation, so I can find out what it is. And we did that. We found that X is 19/4. The problem in here is I've got two unknowns. And so if I can set up an equation, then I need more than one to be able to solve it. I need actually two. If I've got two unknowns, I need two equations, two scenarios involving these unknowns. If I have three unknowns, I need three scenarios involving them. And then I can get rid of one of the variables if there's two, or two of the variables if there's three, and so on. So I can then find the other. As we'll see, that's the idea. So Mrs. B, she invests £30,000, part of it at 5%, part of it at 8%. So what's an equation I could say about this? What could I say about X and Y that must be true? Well, X is what she invests at 5% and Y is what she invests at 8%. That's true. So if I add X and Y together, it won't be 2,100, will it? It'll be 30,000, yeah. So how can I write that as an equation? I can write X add Y is 30,000. So the problem I have is to turn the word problem into a mathematical equation. That's one. Okay? 1, first equation. X plus Y equals 30,000. So what I can do now is I can plot that on a graph. And I did this earlier. X plus Y, down here you can see it on the bottom left here. X plus Y equals 30,000. And if you look at that graph, hopefully you can see that that makes sense. We've got X, the X-axis, and the Y-axis. And if you look at it, when X is 0 down on the X-axis, Y is 30,000. So in other words, you could invest the whole lot. Y represents, remember, Y represents what she invests at 8%. So she could invest the whole lot at 8%, £30,000, or the whole lot at 5%, £30,000. But this is in between. And if we look at, say, this point here, then she's invested £20,000 at 5% and £10,000 at 8%. And so add 20,000 and 10,000 at 30,000. Same all the way along. I could pick anywhere along this and add the x value and the y value, and I'll have 30,000. So I've plotted that. But to be able to find x, how much she invests at 5%, say, I need to know y, and vice versa. I can't solve it. All I can do is plot that and say, well, it's somewhere along this line. What I need is another equation involving x and y. So let's look back at the problem again. What's another equation? Now we need to have in our minds the meaning of percentage. So what's another equation I could set up that does equal 2,100? I'll just pause this while you think about it. Another one would be then 5% of x. And this is 5% of x, times it by 0.05, isn't it? Divide it by 100 and times by 5 to get 5%. Divide by 100 times by 8, in other words, multiply 0.08, and you'll get 8% of y. And those two added together with 2,100. Exactly right. So that's our second equation. So what we can do now is plot that line. So if I go back to autograph and plot another equation on top, y equals 0.x plus 0.08y equals 2,100. Okay. Must have made a mistake. Oh yeah. Equals 2,100. I wasn't writing what I was saying. Okay. There it is. We now know that anywhere along this line, whatever she invests out of her £30,000, 5% at that value, 8% at that value, and so on, then I'll get 2,100 at every point where I add them up. But there's a point where they cross, and that's where x and y are the same in both lines. So that's the point at which her investment gives her £2,100 interest rate at that point. That point is where x and y are the same value. So I can solve it by plotting the two lines and seeing where they cross. This is a nice way to do it because you can see immediately what's going on if you have access to the software, and also you can see that there is a solution because there might not be an answer to the problem we set up. One of these scenarios I've given you might be impossible to solve, and this is a quick way to find out. Plot it. So we can plot them and see where they cross, but of course what I want to do is find an algebraic way to do it. So let's have a look back at this and find the algebra and look at an algebraic solution.